before starting, I will summarize the things that we have learned. We learn about the current. Current is the charge divided by the time. That means how fast the electrons are flowing around the circuit. That will gives you the current. Current measured in amps. Charge measured in coulombs. Time measured in seconds. And voltage is energy required to move 1 coulomb. So energy divided by the charge will give you the voltage, and voltage is measured in volts. Current in a circuit is measured at a certain point, but voltage is measured in between 2 points. So that's when we do questions, you will understand it more. And there is a law called Ohm's law. And in the Ohm's law, it gives you a relationship between voltage, current, and the resistance. So resistance is anything which is consuming energy. So we have any electrical equipment. It can be a laptop, it can be a television, or else maybe a fridge. Anything can be a resistor. So voltage is equals to the current times the resistance. That law we call the Ohm's law. And then we'll discuss about parallel and series connection of resistors. So when the resistors are connected like this, we call them they are in series. And when the resistors are connected like this, we call it is in parallel. And when the resistors are in series, both the resistors have the same current. But when the resistors are in parallel, current will split between the resistors. However, if you look at the voltage, when you look at the voltage across 2 resistors which are in parallel, you have the same voltage across both the resistors. However, it is other way in the series connection. So you have one voltage across the first resistor and another voltage across the second resistor. So in series connection, you have the same current, different voltage. In parallel connection, you have same voltage but different currents. Are we good? Then we discuss about the power. Power can be found if you know the voltage and the current. P is equals to VI. And if you use this one to substitute the V, you can have a power in I and R in terms of I and R. And also if you want to replace R from this one, you get V squared over R. So this is power. So that's the basic things we learned. Then we move to the KCL and KVL. Kirchhoff current law and Kirchhoff voltage law. If you were not in the Monday's class, don't worry about it. When we do questions, I'm going to explain again, like, you know, we'll do together. KCL says, when you consider a circuit, whatever the current coming into a node is a connection point, is equals to whatever the current going out. So current, sum of the current in is equals to the sum of the current out. And the Kirchhoff voltage law says algebraic sum of the voltages around a closed path is equals to 0. So what do we mean by algebraic? I will let you know when we do questions. So we can add all the voltages around a circuit and we can say the total is 0. But we need to add in a way that some are supplying energy, some are consuming energy. So we'll have to consider them as one is positive, one is negative. So we will do that when we do questions. And also we discuss about the current division rule and the voltage division rule. I will explain you this with the example at the end of the tutorial. We have some questions using this one. So we are going to do some questions in a way that we will refresh our memory on the current division and the voltage division. So this is all what we have done so far. Do you guys have any particular section that you haven't understood on Monday? If not, let's move.
Not particularly. Understand most of it.
Okay, that's good. When we do questions again, you will again refreshing the memories. Okay. So first question is, calculate how much power. So they are asking you to find the power consuming in an electric element if it is connected to this many voltage and this much of current. So we know power is equals to VI. These summaries are in my PowerPoint, which I have put in the views. For every module, I have one slide with the summary. So at the end, you can just print the summaries and keep it with you so that you have for the whole 12 topics, you can have 12 slides summarizing everything. Okay, so these equations we are going to use, so you have them in views in one slide like this. Okay, so we have the equation, we just have to substitute the numbers, very easy. So you normally don't get this kind of questions in your exams. However, just to understand the theory, so this is 220 volts times 5 amps. So we have, you can find the power. Power is measured in watts. And energy is measured in joules. We will discuss that later on. So power, how much of power we have? My calculator.
1100.
1100. Do we all get that?
Yeah.
Yeah, that's good. Okay, now the next one. Find the value of R in the circuit of figure 1.1 if the power delivery by the source is, so the power delivered by the source. So this is the source. I told you we can have voltage sources and current sources. How to identify them? This is a current source and this is a voltage source. So you can see the difference between these two. So this is supplying a current. So this can be I, and this is supplying a voltage difference, so potential difference. So this is a voltage. And also this circle means this is an independent source. I hope you remember this stuff. And in case if you have this kind of a current source, that is a dependent source. So we are going to discuss the dependent sources later on. But if you look at this, if you see a circuit with a circle and an arrow, that is a current source. So this is the source. And they are saying this one is giving a power of 400 watts. And they are asking us to find the value of R. When you consider the power supplied by the source, that total power is consumed by these 4 elements. So if you want to find the power consumed by this resistor here, that power is P is equals to VI, or else we can say P is equals to, we have 3 equations for power. If you substitute the V with the Ohm's law, then we have I squared R, or else V squared over I is equals to R. Am I right?
Yeah.
Yes. So we have 3 equations. So you, depending on what you have, you can use any of these. Okay. Now, how do we find the power at 6? We know the resistance and the current. So 4 amps are 4 amps is going out from this. So all the elements have the same current. They are in series. So the power, if you want to find the power here, power should be equals to I and R. So I and R is here. So I squared R. So I squared means 4 squared times 6 watts. So that is the power at the power consumed by the 6 ohms. Am I right? Is that make sense?
Yeah.
Power consumed by this resistor will be 4 squared times IR. And this one should be 4 squared times 2, because the current doesn't change, only the resistance is changing. So here again 4 squared times R. So when you add these powers consumed, that should be equals to 400 watts. Do you agree with me?
Yeah.
So we can say 400 is equals to 4 squared times 6 plus 4 squared times R plus 4 squared times 2 plus 4 squared times R. 4 squared is common to all the terms. If you add this 6 plus R plus 2 plus R, it is equals to 400. So you can divide 400. You can divide 400 by 4 squared, and this will be 2R plus 8. So you can find the R. So R is equals to 400 times, sorry, divided by 4 squared minus 8, and you divide this by 2. Is that right? What do you get for R? 8.5 ohms. Do you get 8.5?
Yep.
Okay, that's
I
good.
had a slightly different method.
Yeah, that's totally fine. What is that?
Well, I just did the P equals I squared R and then rearranged it to get obviously the 400 over 4 squared, which then just equals 25. And then I just took the 6 and 2 off.
That's
and
right.
then
Yeah,
halved
yeah.
it. So
Yeah.
same thing,
That-
different.
Same, yes, that's right as well, yes. Okay. Next one. 120 volt battery is connected. I will do the first few questions and I will let you to do a few other questions, okay? Because some question at the beginning, I will do the first few questions. Battery is connected across a resistor and caused a current of 6 milliamps. So we have a voltage source, which is 120 volts, and we have a resistor here. And this current, they are saying 6 milliamps. 6 milliamps means 6 to the power, 6 times 10 to the power negative 3 amps. And they are saying determine the resistance of the, so they're asking you, I think we did this question before in Monday's class. So R can be found because we know Ohm's law, V is equals to IR. So can find I, which is V over I, and V is equals to 120, and you divide that by 6 times 10 to the negative 3. So your answer is in ohms. So you will get a kilo ohm something. So 20 kilo ohms. Am I right?
Yes.
Yep.
Then they are saying, if the voltage is now reduced to 50, now we don't have 120, we have only 50 volts, and we have the same resistance, which is 20 times 10 to the 3 ohms. Now they are asking us to find the new current. So new current is equals to V is equals to IR. We know that I is equals to V over R. V is 50, R is 20 times 10 to the 3. So this will be 2.5 milliamps, or else you can say 2.5 times 10 to the negative 3 amps. Are we good?
Yep.
Okay. Next one I want you to try. I will do it. So we have few resistors in parallel. So if I ask you to find the equivalent resistance, so you try it. I'll do after you try. I'll give you a few minutes. They are asking you to find the current is 4 amps, and they are asking you to find if the resistance, the light is 30, calculate the maximum number of lights that can be supplied. They're asking how many resistors, the number of resistors. Just think and try. I will do after you try. How did you go with this?
Yeah, I got 5 bulbs.
Okay, let's see. If you want to make it to an equivalent resistor for parallel, this is how you're doing it. Do you agree? And if you add all these together, let's say we have n number of resistors. So if you add these together, you have n over R is equals to 1 over Req. Agree?
Yep.
Then if you want to find the equivalent resistance, if you make it to single resistor, that will be R over S. So now I can simplify this circuit to this. Just one equivalent resistor, which is equals to R over N. And this is 24 volts and this current is 4 amps. Now can you find me the R is given to us as 30. This is 30 is given to us. So if you apply the V equals IR to this, then you can say 24 is equals to 4 times 30 divided by N. So you rearrange this equation and you can make the N the subject and you can find the N. So N is equals to 4 times 30 divided by 24. So this is 4 times 6, 6 times 5. So 5 is equals to N, which is what you got. So how about others?
I did a little bit different.
Okay, but you still got the 5 now?
Yeah.
Okay, yes, that's fine. Yeah, there are many methods, many ways this you can do the same thing. As long as you apply the right theory, it should be fine. Are we good? How about others?
Yeah, I did a different method too, but I still got 5.
Okay, that's good. Okay. All right. Next question. What is the resistance of a coil which draws a current of 100 milliamps, 100 microamps with V is equals to this. So V is equals to 200 volts and I is equals to 100 milliamps for A. And they're asking you to find the resistance, which is easy question. So R is equals to V over I. So V is 200 divided by 100 times 10 to the negative 3 because it is milliamps. So you can find the resistance in ohms. And the next one, again, you do the same thing. Only thing is your current is now not 100 milliamps. Instead of that, you have 200 divided by microamps. So 100 micro means 10 to the negative 6. So you get resistance like this. So they are simple questions. I think we don't need to spend much time on those. Okay. What is the difference here? What is this one?
That's a dependent or what is it? A reliant one?
Yes, the dependent current source. So what is the amount of this? Why we call it dependent? Because this current source, the supplied current is 0.2 times I. I is given in this question, but when you go further, you can see this current is sometimes is unknown. So you need to keep this I. However, here I is given to us. So you can find if this I changes, the current source, the supply current also will change. So here, in this case, you can say this current is 0.2 times 5, which is 1 amp. So this one is giving a 1 amp. Okay, now the question is easy. What they are saying. Calculate the power absorbed or supplied by each component of the circuit. So how do we know absorbed or supplied? All these sources are supplying. So these are the power supplied. So you can find the power here, power supplied, which is equals to P1. P1 is supply. You can write it as supply, which is equals to VI. V is 20 and I is 5. So you can find that, which is 100 watts. This one actually, how do we find the power supplied by this one here? P is equals to VI or else I squared R or else V squared over R. Which one you can use here? You just know the current. So you can go either with this or this. We don't know the resistance. Whenever you have a current source, you don't know the resistance, so you can't do this one. Are we able to find the voltage across this one? Voltage across these 2 points? Do we know that? Voltage is the same across 2 points. So for example, if I have something like this here, and also if I have another something here, and also if I have another resistor and another resistor here. So across these 2 points, the voltage is the same. Voltage is always between 2 points. So do we know the voltage between these 2 points? Is it given to us? It's given to us, isn't it? Voltage across these 2 points is the same voltage here because they are wires. This is the same node. This is the same node. Am I right? Nothing is in between these points. So these two are same points. So this voltage given as 8 volts. So that's the voltage across the dependent current source is 8 volts. Do you agree with that?
Yeah.
So that is 8 volts. Is that right? It is a supply power. Any question? Now the rest is easy for you guys. Then we have 2 resistors. 2 resistors, P2, voltage is 12, current is 5. So this is 60 volts. And P3, the voltage is 8 and the current is 6. So that is 8 times 6, 48 volts. So now you can see power consumed by the resistors equals to the power supplied by the sources. So 108 is equals to 60 plus 48. Are we good?
Yeah, that made sense.
Okay.
Yeah.
That is the main, the basic stuff. Now we have some questions on distribution of electrical circuits and voltage in electrical circuit, current distribution and voltage distribution. So this is a very easy one. We are going to use this throughout the 10 weeks. So let's see how we can do this. 12 volts is our supply voltage. That means between these 2 points, we have 12 volts. That means between these resistors, we have, if you add all the resistors, the voltages across all the resistors, if you measure the voltage across these 2 points, that is 12 volts. Am I right?
Yep.
And they are saying this one is 6, this one unknown, and this one is 2. Are we able to find the unknown VAB?
Yes.
Yes, it is.
It's 4.
4 volts. That's right. Any question? The current is 3 amps. All 3 resistors are in series. So this current, do we know these currents?
Yeah, the current.
Doesn't change. So it is 3 amps everywhere because it is not splitting. It's going all the way around one loop. And then the resistors. How do we find the resistors? Here you know the voltage and the current. So when you know the voltage 6 and the current 3, resistor 1 should be what? Voltage divided by the current, which is 2 ohms. Agree? Can you find me the R2 and R3 as well?
it's just 4/3 for R2 and 2/3 for R3.
Yes, that's right. Anyone have any question? Now, two things. Total resistance and total current. How do we find the total resistance when the resistors are in series?
You can just add them together.
You just add them together. So 4/3 plus 2/3, you add these together and you will get the resistance. So current will be what? The same current, which is
3.
3. And they are asking the voltage across CD. AB we found 4 volts. CD, how do we find for CD? I'm going to delete this, otherwise it is, okay, D is here, C is here. How do we find the voltage from this point to this point? You can either add all the voltages in this way, or else you can add all the voltages from here to here. Both will give you the same answer. Easy path is this path. Voltage is current times the resistance. If you look at this path, you have a current, yes, which is 3 amps. But do you see any resistor between C and D if you consider this right-hand part, the blue part? So the voltage is 0. Am I right?
Yep, I thought it was a trick question there. So I got 0, but I was suspicious.
It is 0. If you do it from the other side, you will find that too. I told you, you need to algebraically add them. So when you go here, from here to D to C, or C to D, this is C to D, so we'll go from C to D. So when you go here, you have a -2 because you're going to the negative side. I told you whenever you are going to the negative side, just do negative sign. So then you have -4. We found that as 4, isn't it? Yes. And this one is -6. And you're coming to the positive side of the 12 plus 12. And that is your D. So if you add these together, all together, then you still get 0. Even though you do the blue path or the yellow path, you still get voltage as 0. Are we good?
Yep.
Okay. Can I give you some time for you to do this, please? It's the same question. So you can easily find this one. What did you get for the VBC?
It's just 16 minus
Yes.
9.
Yes. 8 volts, right?
7.
7.
Yeah, okay, sorry. 7 volts. Now you have all the currents the same. 4 amps. And resistors you can easily find. Same as in the previous one. VBC, B to C, VBC we found 7. AC is 6 plus 7. Do you agree?
Yep.
CD, again the same way, 0. And all the currents are 4 amps. Resistors, we found 3 over 4 ohms, 6 over 4 ohms, and 7 over 4 ohms. Total current is 4 amps, and the total resistance, you add these together, 3 over 4 plus 6 over 4 plus 7 over 4. So that all together will be your resistance, total resistance. Any question? Now with that knowledge, I would like you to try this. Only thing is the resistors are in parallel. Parallel means your parallel means what? At the very beginning, I told you current is splitting, but the voltage remains the same. Comment for all 3 resistors. So keep that in mind, and I will give you a few minutes for you to try this. And you need to find the total resistance. You need to find the 3 voltages, and you need to find the 3 resistors. This is wrong, okay? This is not how you find the resistors in parallel. Yes, this is for series actually. Yeah, so this is from somewhere else, the question. Don't look at that part. And I want you to find the total resistance as well. What can you say about the 3 voltages?
They're all the same.
Yes. What is the value?
36.
36 volts. Okay, now the resistor 1 is current is known, voltage is known, so you can find the resistance R1, which is 36 over 1 ohm. Resistance R2 will be 36 over 2 ohms. Resistance 3 is equals to 36 over 3 ohms. Agree?
Yep.
How to find the total resistance? 1 over R EQ or R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So that is, you can put it as 1 over 36 plus 2 over 36 plus 3 over 36, isn't it?
Yep.
That will be 6 over 36 is 1 over R total. So if you swap this and find the R total, that will be 36 over 6, which is 6 ohms. Agree?
Yep.
Okay, that's good. Would you like to try this one quickly? Or are you okay with this? And we can move to the next one if you are okay. They are very simple. But if you want to try, we can try this. Are you guys okay with this kind of questions? Can I move to the next question?
Yeah, well, this one just looks the same, but
Same, yes.
swapping the formula, so we can move on if everyone else is happy to.
Only thing is you don't know the current. Am I right? You need to find the current. That's the only difference. So your voltage is and the resistance you know. So you find the current. For separately, you find the current I1, I2, I3, and that total will be this one. That's the only difference. Am I right?
Yep.
Okay, voltage will be the same, but you find the I1, I2, I3, and adding these two will be your I4. Okay. Okay, now you have both of this. I will let you to do this. Try this, then I will do. Okay, and this one, I hope you have tried. You may have done it. So 3 volts. And if you look at this one, 3 volts, and this one is 8 volts. So from here to here, that means 3 volts. So what should be the V2?
Well, it'll be the same.
Same 3 volts. What should be the V1?
Sorry, what will be the what?
V1? This one.
V1.
Yeah, wouldn't it?
So from here,
It'll be 5, won't it?
it is 5. Why it is 5? So from this point to this point to this point, it is. So I hope you see my arrows. These 2 points, 5 volts. And from here to here, it is 3 volts. You can't add 3 and 3, and you can't say this is 6 volts from here to here. It is 3. So it's 8 minus 3 will be your V1. Do you guys agree with that? Are we good? Okay, now it's easy. Nothing like you have solved it. So this current is 2 amps. 5 is coming into passing this one and coming to this node. 2 is going this way. So this way it should be 3 amps. Agree? And the 3 and 2 coming again together and going this way as again 5 amps. Am I right? So this also 5 amps. I1 is 5 amps and I2 is 3 amps. I3 is 5 amps and I4 is 5 amps as well because it's the same current. How about the resistance? How do we find the resistance?
Well, now we have all the voltages and the currents. We can just do the
Divide.
calculations.
Yes. So 5 over 5 is the R1 and R2 will be 3 over 3 and R3 will be 3 over 2. Am I right? Are we good?
Yep, that made sense.
Yep.
So we are done with this question. Do you guys have any question up to here? No questions.
Nah.
No, that's good. The only thing I'd say, because, sorry, just go back. When you have a parallel, does the current not drop across a parallel series, parallel?
Current is splitting. Voltage will be the same across the 2 points, but the current which is coming to this particular node where you have the branches, the current is splitting. So current is dropping, yes, through one resistor.
Okay, I understand. Yep.
Because the current is splitting. So whatever the current coming into the node should go.
So it will drop, but it will be proportional.
Yes.
I understand.
So you have two similar questions. I will give you one for you to do. Which one is better? Okay, let's do this. I'll give you a few minutes for you to try this one. This is what you need to find, okay? But you don't have to follow an order, so just think like we did before. Okay, so this one is 3 and this one is 10. So from here to here, the two dots, in between the two green dots, it is 3 volts. That means V1 also should be 3, V2 also should be 3 volts. Do you agree with that?
Yep.
And what should be the V3?
It should be 10 plus 3.
10 plus 3, which is 13 volts. That's right. Okay, now you can find the resistors very easily. Before that, the current I2 should be what? 8 amps coming into this node, 8 coming in. 2 going up, 5 going this way. And what should be the I2?
It's a sum of the incoming, which is 8. So it should be 1.
Yes. So, which is 1 amp. Okay, now you can find resistors very easily, which is 1 is 10 over 8, 2 is 3 over 2, 3 is 3 over 5, 4 is 3 over 1. Am I right?
Yep.
It's good. Any question? So we have one more question like that. I will let you guys to try this by yourself because it's the same thing. Okay, now let's move to the Kirchhoff current law and the Kirchhoff voltage law. We already did some questions like this, but we are going to do it again. do some more complex questions. Find the total resistance across AB and the current I. AB is this. So we need to simplify this circuit. So when we are simplifying, how do we simplify? We look at parallel and series connection. So do we see any straight away? Do you see any two resistors in parallel?
The 40 and the 10 and the 30 and the 50.
Yes, these two in parallel and these two in parallel as well. So if you want to make this to a single resistor, you can do this, which is 1/40 plus 1/10. You can solve this and you can make it upside down and find the RT. But I told you an easier way. Do you remember that? Whenever you have only two resistors in parallel, what you can do is R total is equals to 40 times 10 divided by 40 plus 10. Do you remember this?
Yep, I wrote it down.
Okay, so you can find it easily. That is 400/50, which is equals to 8 ohms.
Yep.
You can do the same thing here. 30 times 50 divided by 30 plus 50, which is equals to 350.
1500.
Sorry, 1500 divided by 5, 6, 7, 80. 150/8.
It's all right, I've already done it. 18.75.
18.75. Okay. Now, let's redraw the circuit now, okay? At the beginning, just don't avoid any steps. Just later on, when you are confident, you can avoid some steps and you can, skip steps. So this is 20 ohms, and this one we just found 8 ohms, and this one we found 18.75 ohms. And this is 24 volts. Okay, now are these resistors, these three, what can you say about their arrangement? Are they connected in series or parallel? After simplifying.
Yeah, they're in series now.
Series. So your total resistance in this case will be 20 plus 8 plus 18.75. Agree?
Yep.
So that will be 46.75 ohms total resistance. So that we know. So across the AB, the resistance, total resistance, if you make it to a single resistor, that will be equals to 46.75. Am I right? So we have simplified the circuit. You have to do this throughout, simplification of the resistors. So you have a new circuit now, simplified version of the same circuit, which is 46.75 ohms, and you have 24 volts here. So they're asking then to find the current coming out of this 24. What is the current coming out now? This circuit voltage is equals to current times the resistance. Total voltage, total current, total resistance. So total current coming out from this source will be 24 divided by 46.75 ohms. Agree?
Yep.
Do you have any question? Any question?
No, it's all clear.
Okay. That's good. I will let you to do this now. You just need to, it's very easy, even though this electrical, you see complex drawings, but when you do it, it's totally easy. You just have to apply the KCL. You don't need anything else. You need to find the currents. Let's do it together. Okay, 12 is coming. 12 comes here. 3 goes this way. So in this way, how much should go this way?
9.
9.
Okay.
Now 9 is coming here to this. 1 going this way, 2 going this way, 9 coming this way. So what should go this way? The diagonal way.
6.
6. So that 6 and 3 comes here. We can't find it because we don't know 3 of them. Okay, now let's see. Okay, so 2 is coming here. 12 going this way to this point A. So what should be this current?
Be 10.
It should be 10 amps. Now 10 is going this way, so I don't think we can do it yet. Okay, so 1 going this way and 2 goes this way. 5, yes, so 5 is here. So what should be the I2? I2 should be what?
It's like 5 minus 10 or something, isn't it?
Yes, so -5, am I right?
Yeah.
So that means the arrow should be downward, but arrow is given, so our answer should be -5. So -5 is coming this way, or else if you want, if it is confusing, you can put the arrow down and you can, like, so -5 is coming this way. 2 goes to the right, and this is 1. So you have 1 here, and you have 2 here, and you have -5 here. What should be this I? I minus 5 should equal, so what are the currents coming in?
So it'd
Is
be
it
like
coming in?
-5 plus 1 and a -2.
Yes, so 1 minus 5 is equals to 2 plus I. So I is equals to 1 minus 5 minus 2, which is equals to -6. Agree? Is that right?
That's what I got, yeah.
Okay, it is -6.
Is there such thing as a -6 current?
-6 current means arrow current is not going upward, current is going downward. Negative means the direction is wrong. 6 is the magnitude. The assumed direction is opposite. That's what the negative sign says. If it is confusing, you can say you can draw it and see. So -6 means arrow downward this way. This -5 is 5, not this way. 5 is opposite direction. The arrow is opposite this way, 5. And 2 is going this way, and 1 is coming here. So now I think if you look at now, we have 6 and 1 coming in, and 5 and 2 going out. 7 coming in, 7 going out.
Yeah.
Okay. How about this point now? So 3 going like this, and 6 coming like this. -6 is opposite. If you want to put it like negative to positive, you can make this. I think we still can't do that, right? We don't have to find it. We already found everything. We don't need to find. I think we don't have enough information to find the rest anyway. But they're asking us to find this one. We found that, which is 10. They ask us to find this, which is -6, and they ask us to find this one, and we found that. Are we good?
Yep.
Okay. I want you to try this now. The same thing, only a different picture. Same concept. I think you can start at a known point, 2 all known, only 1 unknown. So you can start from here. So 5 coming in, 6 going out. Is that right? So what is I2?
Negative
Minus
1.
Negative 1 amp. If it is confusing, you can put negative 1 as I2, but to do the rest of the questions, you can put the arrow in the opposite direction and you can make it. So this way, it is 1 amp. So minus means this arrow is wrong. And 5 is coming in, 6 is going out. But your answer you should give as negative 1 because that's your answer. But now you can look at this point here. 1 going towards the right, 8 is coming in. So this should be what is going out, going down should be 7 amps. Am I right?
Yep.
If you look at this point now, 8 going this way, 2 going this way. So how much should come as
Yeah, it's 10.
10? Okay, now look at this point. 10 going this way, 5 going up. And what should be this?
15.
15 amps. I think we found all.
Yeah, you could do it from the other side as well.
Yes, you can do it from this side as well. Yes, doesn't matter.
You can also start at I1 because you got the 8 and 2.
Yes, yes. Wherever you know 2, and if you don't know just 1, you can start at any node which just with 1 unknown. Yes, that's good. They are very simple, but your questions won't be like this. You are applying these questions for complex circuits, but we are now going to put the foundation for that. When you have the foundation, you don't have to worry. You are all good. Now we are going to do the Kirchhoff voltage law. What did I tell you when Kirchhoff voltage law says algebraic sum of the voltages around a loop is equals to 0. So we can write it. So we have 3 loops, 3 meshes here. Actually, loop is just any closed path. So we can consider one at a time, one closed path at a time. So this one, I'm going to consider this red triangle. When applying a KVL, we start at a point and we go around in any direction. It's up to you which direction. So I'm going to go this direction. Whenever you are entering a negative sign, that means you have to minus that voltage. So minus 15. Then you are going to a minus side of this. So minus V2. Then you are going to the positive side of 6. So positive 6. And you're coming back to this point is equals to 0. And you can now find V2. V2 is equals to negative 15 plus 6, which is negative 9 volts. Is that make sense?
Yep.
Can you find me V3 and V1 as well? Just find V3. We'll do the V1 together. Start at a point, go around the loop. So you can start at any point. I'm going to start at this point. And you can go in any direction. I'm going this direction now. If you go in the other direction, doesn't matter. Okay, so this is positive 12 and negative V3 going to positive 15 is equals to 0. So I can say V3 is equals to 12 plus 15, 727. Are we good?
Yep.
For doing V1, you have many methods. Very many loops, many meshes. So you can start from here and you can go like this because you already know V2 and V3, or else you can go like this. It doesn't matter. Any path, any closed path is fine. I think the yellow path is if you look at the yellow path, only unknown is V1. We already found V3 and V2, even the other path is okay, but it's up to you. Any closed path, even it also can be this path. It doesn't matter. You can go like this. If it is, as long as if it is closed path, start to end, you can start from one point and come back to the same point. It is a closed path. So you can use any closed paths. Okay, so I'm going to just go this way. But it's up to you. You can do any one. So I'm starting this point, going to a +6, going to +12, and going to negative V1 is equals to 0. So V1 is equals to 12 plus 6, which is 18 volts. Are we okay with this KVL?
Yep.
It's good. Okay, can I give you this for you to do, please? You just need to find V1 and V2. It's an easy one. So you can start at a point and go like positive V1, positive 12, negative 10, negative 5 is equals to 0, coming back to the same point. So V1 should be equals to 10 plus 5 minus 12, which is 3 volts. Is that what you got?
Yep.
Yes.
Okay. Another path, start at a point. It's up to you which point to start. So I have positive 10, negative 8, negative V2. V2 is equals to 0. So V2 is equals to 2 volts. Am I right?
Yep.
Okay.
Yes, I got
That's good. Now the next one. So far, in all the questions, you had the positive side and negative side to do the KVL, apply the KVL. But in some cases, you don't get the positive and negative for the resistors. So resistors are always, when you don't have, it's not given. When it is not given, the positive side and the negative side, what you have to do is, you have to put consider the current is always coming into the positive side because they are consuming energy. So current should be comes to the positive side, considering that you put your own positive and negative. The current direction is given to us. Am I right?
Mhm.
So we put the positive and negative according to the given current. In some cases, we have to assume the direction of current. If we assume the direction of current, we do the positives and the negatives according to that. But in this case, they have given us the current. So always resistors, current is coming into the positive side because they are consuming energy. Okay, now the same thing. They're asking find the current IR and the voltage V out for the open circuit B, if the resistor of R is replaced across the output terminals, determine the current. Okay, we'll do the A, part A. What they say is we need to find the current now. And the output voltage. The current and the find the current RA and the voltage V out of the open circuit. It is open circuit. If it is open circuit, you need to read this properly. Open circuit, what should be the current?
If it's open, it's turned off. It's 0. Yeah.
Yes, there is no current. Current can't flow if there is no connection. So IR is 0. Agree?
Yeah.
Can we say the voltage also 0? Is the total voltage 0?
Is it stored voltage or?
Voltage is 0 here and here. Because why? Voltage is equal to current times the resistance, where there is no current flowing. So the voltage across resistors are 0. Both voltages across both the resistors are 0. But these are not 0. There is a supply voltage, even though there is no current flowing. Consider a battery. Battery has a voltage. Am I right? Similarly, there is no current flowing because no connection. However, there is a voltage. So what is the open circuit voltage? You do the same KCL. You apply, you can go by this way or that way. It doesn't matter. So you go around the loop and you add the voltages. So you start at this point. Okay, you can start at any point. Just start at a point. Go up along the loop. So this is -5. Coming here, +12. Going +3. 0, 0 resistors, no voltage. So negative V out. Coming back to the start point is 0. So what is the V out?
10.
Yes, so that will be 12 minus 5 plus 3. Is it 10?
Oh, that's what I calculated.
Okay, 5 is, yes, sorry. Yes, that's right, 10.
You had me worried there, Yupika.
What's that?
You had me worried.
Yeah, the simple maths, it's now like, the brain is getting old. Okay, now we are done with that. No, the part B. Now they are saying, if the resistor of the R is replaced across the output terminal, replaced across the, determine the current IR when the voltage, resistor of R is replaced. Replaced with what? Replaced. Okay, so here now we have to have R. Am I right? That's what they're saying.
Yeah.
Another R, yes. So then again we have we have the current going in this way. So this is positive and this is negative. Now they are asking us to find the voltage. V out is again the voltage across this new resistor, and we need to find the we apply the KVL again. So when we apply the KVL, you start at a point. So this is our positive, negative, positive, negative. You go around this. So it's up to which direction. So you have positive R times IR. Am I right? V is IR. Isn't it? Plus, again, IR. Then you have 3 volts, negative, because going to the negative side. Negative, and -12 plus 5 And again, coming to the positive side, so positive IR is equals to 0. So if you look at this, you have 3 IRs, voltages, all three are the same. So 3 times IR is equals to, sorry, minus 3, minus 12, plus 5 is equals to 0. So 3 IR is equals to 10, as you got before. Am I right?
Yep.
So IR is equals to 10 over 3, which is your V out. Am I right?
Yes.
Because that is your V out is the IR, this IR. So that one we found this many volts. 10 over 3 volts is the V out. How can we find the current now? Determine the current. Total voltage across this one is 10. Am I right?
Yep.
We can't, R is replaced across the output terminal. Determine the current. We can't find it without knowing the value of R actually. We can't find the current without knowing the resistance. There is no way to find the resistance. We can't find the I without knowing the, yeah.
We can't find the I. Can't we just say it in an algebraic term?
Yeah, we can say that should be 10 over 3R should be I. Am I right?
That'd be as much as far as you could go.
Yes, that's all we can get without knowing R, the value of R. We can't find a number for I. But yeah. Are we good?
Yep.
Okay.
Now, I couldn't work this one out, Yupika, when I was doing them.
Okay, how about others? It's a easy one, yes. So this one is easy. You guys can do it if you want to.
Oh, I tried and I couldn't do it.
You couldn't. Okay, okay. We'll do it then. Okay, let's do. Find I, V, and the power dissipated. For power, let's do the power later on. So what is happening now? We are going to apply whatever the things that we have learned. We can use simplification of resistors to find, do things. Okay, so 10 is coming up to here. 10 is coming up to here, am I right?
Yep.
Then it is splitting between two branches. We are going to apply current division rule now. So these two resistors are in series, am I right?
Yep.
So you can make it to a single resistor, which is 10 ohms. And this is 2 ohms. And you have 8 here, and I'm just simplifying the circuit. So you have 10 amps here and 8 ohms. So I just added the two resistors in series. Is that right? So 10 coming here, 10 amps coming here. Now it is splitting between two branches. We have something called current division rule. What that means is, if I take this as I1 and if I take this as I2, I1 is equals to 10 is the total current times opposite resistance. If I look at the I1, the opposite resistance is the 10. 10 divided by 10 plus 2. So this we call the current division rule. Current is always like to flow in the easy path. More current is going through 2 ohms and less current is going through 10 ohms. So you can find I1, which is 100 divided by 12. Is that clear or not?
Yep.
So 100 divided by 12, 8.33. Okay, now what should be the I2? You can apply this same theory. I2 should be 10 is the total current. 10 times the opposite resistance, which is 2, divided by 10 plus 2. So that should be 20 divided by 12, which is equals to 1.67.
You could just subtract
Yes,
the...
yes. if you have done this right, you should get these two added to 10.
Okay, yeah.
Or else, if you don't want to do this one, you just can minus from 10 and you can find the other one. Okay. So we found I, am I right? When you find I, that is 1.67 amps. And this voltage V should be 6 times 1.67 volts, isn't it?
Yep. Okay, I see.
That
Yep.
will be 10 volts. That's all they're asking us to find, isn't it?
I and V, yep.
Power is VI. Power here is VI. So V is 10, I is 1.67, so that will be 16.7 watts. All good.
Yeah, yeah. I think I misread it because I was trying to find IV and power just from that one resistor.
Ah, okay.
Anyway, that was good. That was very good.
Yeah. Okay. So can I let you to do this one? You are applying the current division rule here. I'll give you a few minutes here to try this. Simplify this. You can simplify these two and you can have just two resistors and you can apply the current division rule. So you can easily do this with the easier way. 20 times 30 divided by 20 plus 30. Am I right?
Yep.
20 times 30 divided by 50. 12. So this is 12 ohms. And the other one will be 10 times 40 divided by 50, which is 400 divided by 50, 8 ohms. Am I right?
Yep.
So how this is splitting? How this is splitting to the two sides. So if you want to find this one, I1, let's say not I1, let's put something else. IA or something. So this is IA. And IA is going towards the right. And IB is going towards the left. So this is IB. If you want to find IA, that will be 20 times opposite resistance, which is 8 divided by 20, 8 plus 12. So this is 8 amps, am I right? If you find IB, that should be 20 times opposite resistance, 8 plus 12, which is equals to 12 amps. Are we good up to here?
Yep. Yeah, I got that.
Okay, so 8 is going here and 12 going to this side. Now just look at this part only. So 12 coming into this node. I1 is going across 30 and I2 is going across 20. So how can you find I1? That should be 8 times 20 divided by 30 plus 20. Do you agree with me?
Yes.
And the I2 should be 8 times 30 divided by 30 plus 20. Similarly, I3 you can write as, now the total current going towards the left side of the circuit is 12 amps, which we found before, and that is 10 divided by 10 plus 40. And I4 will be 12 times 40 divided by 10 plus 40. So that is the current division rule. So you can find all the currents. When you add all 4 together, you should get 20 if you have done it right.
I didn't get to calculate them. You're too quick for me.
So no, you take your time and do it. We only have few more questions. This is the last question. Yes, we have time. Please do it by yourself, and we don't have any voltage division questions. Yeah, voltage division questions are not here in the tutorial, but I will find a one and we'll do it later on, maybe next week. So you do by yourself, okay? Don't look at this. You don't have to look at this. You have understood the concept. And when you finish...
Yep, no, it's added up. I've got the totals. One side equals 8, the other side equals 12.
Okay, so both the sides altogether will be 20, right? All 4, if you add them together, I think you get 20, isn't it?
Yep.
Yes, which is good. How about Lachlan and Matt? I hope you guys are okay. These are the 20 questions actually we have. We have done almost all the questions. Do you guys have time to do one question with voltage division, or otherwise I can find one and do it next week, the beginning of the class?
Whatever you want to do, you pick it, I'm happy.
Voltage division is easy, so I'll show you this one as well, so it is complete the whole week one. Let me find a question. Okay, so current division. This is also current division. Yeah, I will take my own question and we'll do it. Okay. Okay, so current division rule is applied when you have resistors in parallel. Because current is splitting. But when you have resistors in series, you have the same current, but the voltage is splitting. So let's take that we have a 20 volt total voltage, and I need to find the voltage V1 and V2. And this resistance is 5 ohms, and this one is 10 ohms. Now, voltage division rule says if you want to find the voltage V1 is equals to 12 times. In the current division rule, we consider the opposite resistance. In the voltage division, we don't consider the opposite resistance. We consider the same resistance. That's the difference. 5 divided by 5 plus 10 volts. If you want to find V2, that will be 12 times the same resistance to V2, which is 10 divided by 5 plus 10 times V. That's the only difference. Current always the opposite resistance divided by the total. Voltage division says the same resistance divided by the total resistance. Does that make sense, Glenn?
Yes, yeah, it's a bit tricky that I'll have to do a bit of practice to remember.
Yeah, okay. Yeah, we